Hello there, welcome to Kerbalized Realism. I'm Foxworth Kerman. We start out at LK-14 in Cape Canaveral on December 6, 1964 for the launch of Viking 2 on its way to Mars to be the first to fly by the Red Planet. Viking 2 was intended to be a backup in case Viking 1 failed on its way to Venus. That mission was successful, and the Mars window opened, so KASA took the opportunity, Viking being my analog to Mariner. If you're wondering, Viking 2 now being Mariner 4, let's learn some history. Mariner 4 was launched November 24, 1964. So we're pretty much on par with NASA. Launched on Atlas LV-3 Agena D, my analog is the Agave. Mariner 4 made its closest approach July 15, 1965. The mission lasted 228 days. Mariner 4 was the first spacecraft to return up-close photos of Mars during its closest approach at about 9,846 kilometers or 6,118 freedom units. It took 21 images over a span of 25 minutes, showing a cratered moon-like surface, disproving the thought of life and an Earth-like planet. The photos were stored on a magnetic tape recorder that transmitted at an abysmal rate of 8.3 bits per second. The ground team was so excited they started hand coloring the printouts before they were fully received. It was revealed that Mars had a very thin atmosphere, mostly consisting of carbon dioxide and only about 0.6% of Earth's pressure. A few technical aspects: it weighed 260 kilograms or 573 pounds. It was powered by solar panels and rechargeable batteries. It included a TV camera, a magnometer, a cosmic ray telescope, a Geiger counter, solar plasma probe, and a dust collector. The mission's tape recorder was a crucial piece of tech. If it had failed, none of the images would have returned. The public reaction was quite mixed. There was awe at the achievement, but there was much disappointment of the lifelessness of Mars. And there, our Viking is detached. Well, as it floats all alone, we'll transition to another launch as we transition over to LK-17 on April 16th, 1965, putting up the first geostationary satellite, SYNCOM, on a Delta D. I couldn't be bothered to change the name in this one, especially once I realized I was already late on the timeline. I just wanted to get up, complete the contract and the milestone. Launched to 150 kilometers, and then pushed out to the geo height, where the plane changed to an equatorial orbit and circularized. So, SYNCOM is short for Synchronous Communications Satellite. NASA launched SYNCOM 1 and 2 to be near synchronous orbits, but not fully stationary. SYNCOM 3 launched August 19th, 1964, and became the first stationary satellite. In case you don't know, geostationary satellites are in orbit where they orbit the planet at the same rate the planet rotates, making it appear to hover over the same spot, making it perfect for continuous communication coverage. SYNCOM 3 was used to broadcast the 1964 Tokyo Olympics, being the first live broadcast between the US and Asia. Arthur C. Clarke proposed the idea of geostationary satellites for communications in 1945, almost 20 years before SYNCOM 3 was launched. Heck, that was even before any satellite was ever launched. One thing most people don't know: SYNCOM was initially developed for military communications. After reaching geostationary orbit, SYNCOM 3 was used to test the military communication capabilities of secure voice transmission, teletype data exchange, and the potential use in military command and control infrastructure, as it was relevant in the Pacific theater. It was parked 180 degrees longitude directly over the Central Pacific Ocean. It was not chosen at random. It gave line of sight coverage between the U.S. West Coast, Hawaii, and East Asia. It allowed direct communication links with U.S. military bases and naval forces operating in that region. With the Vietnam War escalating, the U.S. military recognized the value of a constant, secure global communication, especially managing deployments in Asia. Satellites like SYNCOM were the early steps in developing real-time battlefield communications, intelligence sharing, and nuclear command and control. As I turn to look at the screen, well, look at that. It's finishing that orbit. And then it's going to decouple the little satellite. And there was even enough fuel left to deorbit. So how about enough history? And let's watch this thing go kaboom as it re-enters the atmosphere. Separation confirmed, although unfortunately you see up in the corner of the screen going green and gray and green and gray. Yeah, the actual satellite, the little solar panels on it wasn't enough. I don't know if it was Realism, the KSRSS, whatever. It just wasn't picking up enough and couldn't stay powered. But hey, we still put it in geosynchronous orbit. We're gonna pretend it's there doing the stuff I was talking about. Oh, and here's that bomb stage exploding, like I said. Now let's go back to Mars. Back at Viking 2 has just entered Mars' sphere of influence, and it's getting all kinds of warnings. Solar panels are degrading, reaction wheels are needing repair. Let's say it now and get out of the way. Don't forget to like and subscribe. Hit the bell to be notified, that kind of good stuff. And in case you can't see it, the arrow is pointing to Mars. I couldn't figure out that was Mars for the life of me, even as I'm getting closer. And then you see how it starts popping up here and it's showing like Phobos. I was thinking that was Phobos, not Mars. So I'm looking around like, where's Mars? Mars has got to be here somewhere. But no, Phobos is just there that you can't see it, it's so goddamn small. That's Mars that I'm looking at. Eventually we're going to zoom in on it here. So, here we go. Let's get close and do our flyby. But if you've seen the thumbnail and such, and the name of the video, it's not a flyby. Something went wrong. At this point I started to go, why does it seem like we're just getting closer and closer? You see the dust storms are pretty cool down there though. And it is awfully cratered, like I was saying earlier. But there has been mistakes. Because yeah, we're out of power. I ran out, well, not out of power, but I ran out of communication. So I couldn't make a correction burn. And I didn't think we actually got this close. But before I knew it, it was in the atmosphere. Yeah, those bright spots are the dust storms. And I'm like, what's going on? Then I realized, oh, it's exploding. It's done for. We clipped the atmosphere. I didn't know we were that close. I guess I better check what the atmosphere of Mars is. I was thinking that Duna, like it was 40, so I thought that was plenty high enough. No, we were definitely in it at 70, so. I'll wrap this up. Thank you for watching. Thank you for exploding and checking out Mars. Hopefully we'll be back here soon. Goodbye. Look at the dust storm. Oh, the dust storms are neat. But why are you hanging out? The video's over. Go away. Goodbye.